Find where the gradient is. Find where the gradient is 7 on this graph. So we need a gradient function, clearly. So let's get the gradient function. The gradient function is y dash. So that will be 3 times a third. And we want to know where the slope is 7. How do we solve that? Yes, it's a quadratic, which is x5, I'm hoping, yes, null factor law. Rightio. So we've got 2 answers for when the slope is 7. How does that make sense? Okay, well, it's a cubic, isn't it? It's a cubic, and we want where the gradient is 7. So 7's pretty steep. So there's one point that's got a gradient of 7, and there's another point that's got a gradient of 7. Clearly that's my 3, and that is my -5. Makes sense, doesn't it? Find where the gradient is 0. So we've already found out that y dash is... And we're going to set the gradient to, because that's the same function as before, equals x squared. We know we're going to factorise it, use the null factor law. Gosh, that was hard. X plus 4. So there's going to be, what is that? X equals... So there's 2 spots where the slope is 0. So, bang, bang, bang. Not to scale, just quietly. So can you see here, we've got a gradient of 0. 0 means it's horizontal, there's no slope, it's flat. There's one spot, and it happens at -4. Here's another flat spot. It happens at 2. Okay, these flat spots are called things. They're called turning points or stationary points, depending on which question and what textbook and who's writing it. Turning point, stationary point, both mean flat spots, which is a minimum or a maximum in words. Okay. You would know that when we graph functions, we usually put in x-axis intercepts, y-axis intercepts, and to date, we haven't really worried about, well, we sort of know that we want to, and we can on a parabola by completing the square, but on a cubic, we can't find that point there. But guess what? We can now. We can through calculus. We've found that that point happens at -4. I'm going to put -4 into the function to get the point. So this thing as a point is the point -4. Calculator away. 28 2/3. So this is the point 28 2/3, and this happens at -7 1/3. Just using your calculator, I'm just putting 2 into the original function. Okay, so we not only found where the slope was 0, because it was at -4 and 2, but we also found the value of the function at those points. Hey, there's an object that's speeding around somewhere, and it's got its speed is modelled by this velocity time graph. Yes, that looks familiar, doesn't it? So, what's its maximum velocity? Okay, so first up, we need to go... That line keeps going up, doesn't it? So it's sort of got an unlimited or an infinite velocity. So we're going to start to talk about a limited domain and go, within the domain that we can see, where's a maximum? And we're going to go, well, maximums happen at the top of a point and minimums happen at a bottom. Just like parabolas have maximums and minimums, so do cubics, but in a prescribed domain. Okay, so maximum velocity will happen at this point here. The velocity is the value of the function. So what's the maximum velocity? 28 2/3. Its minimum velocity is down here. The velocity is this thing here, which is -7 1/3. Hey, at what time did this maximum velocity happen? Well, it happened at t equals -4. Well, that's interesting that we're time travelers now, but you get the point. Where was my minimum velocity? It happened at t equals 3. So after, was it 3? Sorry, it was 2. So after 2 seconds, it had its minimum velocity. And that's where we're getting to with differentiation, is different applications. So abstract ways to graph functions, but also minimums and maximums of worded questions. Okay, get to it, have heaps of